So our next mechanism is going to draw a curve which is known as a virtual parabola, not an actual one, but a virtual one. Here's the mechanism and the curve. The one there. As you can see, the mechanism has got a couple of it's got a gear pair attached to it, so relatively interesting looking mechanism. So here we'll start with the gear pair. I'll do it like this. Each of these gears is going to have a radius 1, or R rather, not 2, 1. But they're the same radius, so that means the angles are going to work out to be, there's going to be the same angle differential in one direction as in the other. Now, we have a kind of fixed line here, and we have a couple of links come up like this from this one. So this fixed line, we need to engineer it so that this length is A. And let me, just to enforce that it's sort of in the background, I'm going to make that grey. And then meanwhile, we have another line coming out of this center. And this is attached to a fixed length link attached to D. And this length is also A, as are these two links. Now, we need to engineer things such that AF is the same as CG in length. So the way I'm going to do that is I'm going to make this angle here theta. And at the same time, I'm going to make this angle here theta. So the fact that these are coordinated, this reflects the behavior of these links. So let's just, so this line AE is attached rigidly to this gear, the gear centered to A, and then the line CG is attached rigidly to the link centered to the circle centered at C. So as we change theta, these links should look like they are operating as gears. And you can see that, yes, indeed, the lines are rotating at the same speed in opposite directions. So that is behaving itself. Now, the question we have is, did we get things right? If we got things right according to the book, then the distance from A to F is the same as the distance from C to G. So let's just check that. Distance from A to F, 2A cos theta, and distance from C to G, to A cos theta. So we're good. Now, all we need to do to complete the mechanism is give ourselves a link here that is perpendicular to the y-axis, and where we maintain the perpendicularity at H. So now let me just change the limits minus 1.57 to 1.57. And theta and have a look at what the locus of H is. And so here is the top half of that virtual parabola. Let's have a look at this equation. And there's the equation, relatively straightforward. Equation R is the radius there of the circles, and A is this parameter, which is the length of a variety of the links. So let's just animate it to complete our model.